and welcome to a special edition of Highways Presents. We've got a range of guests today, all talking about a very special programme launched by National Highways. It's the £400 million concrete road maintenance and upgrade programme. It covers about 4% of the strategic road network in England. And what's really special about it, not just its size and its commitment to upgrading roads which were originally laid back in the 60s and 70s, but more importantly, some of the massively innovative approaches that were taken to upgrading these roads. Everything from new approaches such as diamond grooving to change the way we do maintenance to add longer life to existing concrete roads, to what we're going to be talking about today, which is the use of digital innovations, AI, and other means to really map out the road network and identify areas where we can best exploit modern technology to build a longer lasting, safer motorway network and a road network, I should add. We've got some wonderful guests here today. I'll let them introduce themselves. Mark, would you like to kick off?
Hi everyone, I'm Mark Reed, Professional Services Director at KOREC Group. KOREC are a supplier of geospatial survey and mapping technology, and we've been working with National Highways and the Concrete Roads Framework for the last few years to evaluate and implement different technology that can be used to help deliver the Concrete Roads Programme.
I'm Michael Ambrose. I'm the technical lead for the Centre of Excellence for the Concrete Roads Programme.
Hi, Jessica Tuck. I'm a technical director at AECOM. We're a designer under the Concrete Roads Framework, and also supporting with some of these innovations that are coming through.
So, Concrete Roads Programme, could you guys lay out for me how AI and modern digital mapping is helping provide insights into the wider Concrete Roads Programme?
The Concrete Roads Programme for the first RIS period, which is 20 to 25, is one of a future possible 6 RIS periods. So this is a programme that will be around for 30 to 35 years. So getting it right at the beginning and using digital techniques is important because it will show long-term benefit for us as we move forward. Being able to track where we need to do repairs, the repairs that we have carried out are then consistently mapped, if you like. So it's a part of using a digital mapping is the repeatability of the survey over the exact same points to see how things deteriorate. An early part of the programme meant developing an AI, which both Mark and Jessica have been working on. Basically, we're updating that now to get it more accurate. We had an initial version which Mott McDonald's produced, but now we're moving on to a much more accurate version being developed by KOREC and AECOM at the moment. So perhaps I'll hand over to Mark to explain a bit about the update that we're working on.
Yeah, I think from the outset on the project, it's a case of data-driven decision making. You need data to inform your decisions. And I think when we reviewed along with AECOM and Mike at National Highways at the start, it became quite evident that we need a single source of truth, an accurate digital record of what the as-is current existing condition is that everybody can use throughout the project. And I think that was one of the initial aims, is how do we capture that information? How do we get that information in a way that can enrich and inform the design information, the decision information, but also do it in a way that's not going to kind of impact the road users and the traffic which is there. So, when we look at data, we kind of need that data for 2 applications, I think, within this project. One is to obviously inform the investment and the prioritization of which roads we need to repair and work on first, but also how we can then use that data to actually take that further and inform and speed up the actual scheme delivery itself, whether that's to inform auctioneering or use digital processes for construction and handover. So that need for that kind of golden thread or that digital representation was very clear from the outset. And we all worked with AECOM, National Highways and the wider framework to develop what we're calling end-to-end digital. So this is, an approach to try and use digital technology all the way from the outset in terms of the digital survey, and then taking that all the way through to actual digital design, digital construction, and digital handover. And 2 of the kind of key elements of that process, one was was to deploy mobile mapping, so driven surveys that can be undertaken at normal traffic speeds. So what that means is we can survey the existing roads very quickly and efficiently, gather a huge amount of data to inform the optioneering process, but like I say, doing that without any road closures or disruption to the network. And from that survey, we get some really rich 3D LiDAR information as well as imagery information and a very detailed picture of each of the concrete road schemes. One of the kind of the challenges with that kind of technology is that we capture so much data. The data is only good if you can extract the value from it. And the way that we can extract the value is by starting to deploy AI and machine learning technologies to actually automatically review this information that we've captured and extract all the information out of it that we need to feed into the downstream processes. And that's really where the AI piece comes in, where we can actually automatically look at the defects on the road from the survey information that we've got and plot those out very, very accurately. And then that information can then be used both for the deterioration modeling to understand which schemes we need to prioritize, but also that same information, because we've got that very high location accuracy, can be used for actually the design as well. And I think that's one of the kind of the special things that we've done here. Is it's not just a high level which roads do we need to work on, it is actually using that information to actually deliver that efficiency in the scheme delivery all the way through.
I think it's a good point, Mark, but I think that a huge part of the value that this solution is bringing is the way in which that data is shared and deployed to the people that need it and who are using it. So certainly from a designer's perspective, to have the data available, accessible, and together in one place it delivers a huge efficiency when it comes to scheme development and design.
Every bit of data you collect is useful for years to come. So a good example of that is where we do the repairs now. We might not do all the repairs to all the defects. So typically we only repair about 40% of the defects on the pavement we find. Therefore, we've got an accurate record of what we did and didn't repair, if you like. So then it helps with the proof of deterioration curves, if you like, about the accuracy of those. But it also means that when we've gone through from initial design, optioneering, etc., and we're into detailed design, designers can put that back into the portal for use on the construction sites. And where our constructors have been using the portal, it's been invaluable. And so instead of walking down the road late at night with a paper map in hand to map it out, you actually walk down with the tool and you know you're accurate, you're not trying to find your way. It sounds simple in the sense that you think on a carriageway it'd be very easy to find exactly where you are, but in practice it's difficult, particularly as several repairs or defects may look the same. So actually being able to pinpoint them with 2 centimetre accuracy or greater accuracy is extremely useful. And it also means as well, where things happen on site where you need to do a slightly bigger repair, and then our quantity surveyors have a discussion afterwards between each other about how much did you repair, what depth was it, and how large was the actual repair, the materials used. Because you can take a photograph or a video and record it and actually show on exactly the road where it was repaired, it saves a lot of the post-work arguments between the QS teams about what was actually done. You have a good audit trail, good proof of the work done, if you like, through the end of the construction period. Now, the advantage of using the portal for us is not only can we see it on a little handheld computer, but we can also see it in virtual reality or augmented reality. So we can put our helmets down or our glasses up and actually see where the intended repair was supposed to go. We can also ask for quick decision making. So typically if a night shift's been done the night before, I can come in the morning and there'll be a list of reports about we need to do some extra work here, we did some extra work, are you okay with that? So I can see very quickly and very informatively exactly what was done and what's been agreed to, if you like, on site that night that was different to the original design. Part of the rapid communication, if you like, which tends to be much more delayed between sites. There'd be photographs, there would be email chain in the morning when the person who woke up off night shift. Because this is actually done on shift, it means that the detail is there for you straight away. And The nice thing is when we complete the whole project, rather than wait for months for the as-built to come in, the as-built are ready 5 minutes after we leave site. So that's one of the bigger advantages as well going forward. Hence the reason why we call it the golden thread, because once we have the as-built, those move into the asset management side. So you have a really good, clear record going forward. And so once you start the golden thread, effectively it runs through until such time as the road changes its nature. So for us in the concrete roads program, that would be reconstruction, where we change it from a concrete pavement to an asphalt or composite pavement. So from our point of view, that might be 15, 25 years away. So seeing what you've done on the road up to that point in time allows you to make good investment decisions about the level of intervention to keep it going forward. It's not just about mobile mapping and the AI, it's about the whole concept of digital working, if you like, going forward and being safer and more astute on sites. So where we've used this in the RIS2 period so far, we've seen quite large efficiencies, around about £30,000 for small schemes to about 154,000 for large schemes. And I think those will only improve over time as we start to deploy all the functions we have within the portal itself.
Yeah, no, I think you make a good point there, Mike, because like I say, when we talk about digital twins, you know, that they're not static, that they are dynamic. That central model we have is maintained and updated. And I think one of the things we learn is speed. So the shorter the time lag between us doing a survey or repairing something on site and actually getting that information back in the central environment for all stakeholders to look at, there's huge savings there, both in scheme delivery, but also identifying potential problems and rework and the cost savings that are implied by that. And I think just going back to one of the points that Mike made there at the start is the importance of location. And actually, for us as working in a survey geospatial business, location is what we do every day. But when we came to look at this problem on highways, it became evident that location is so important, because even now today, a lot of things on the highways, everything is positioned by a section and a chainage, and that can vary depending on which type of section or which chainage model people are using, which mileposts, and actually a simple idea of actually using GPS and having a coordinate for everything accurately and having technology that enables that is a real game changer to give people location information at scale for scheme delivery. And I think the other piece is when we're trying to create a digital twin, we're layering lots of pieces of information, whether it's existing asset information, whether it's new survey information, and the way that we can bring all that together is by location. So that spatial element is really, really important in what we do.
All right, brilliant. So we've got very, very detailed mapping that can be easily shared through this portal you've been talking about. That's where all of the data goes. Michael, can you pick up on that and how this portal, where all the repository of all this information, how does that inform the maintenance and the works of the future?
So what that has allowed my team to do, who are working on new and innovative materials for the actual network itself, we've installed about 3,500 innovative repairs around the network so far. And it allows us very easy monitoring for that. So every time we do a survey, we can check to see whether it's performing as we'd originally wished, or whether it's not performed. So where we put, for instance, flexible materials in for repair, what the state and condition of those is, have they held, have they worked, and same with the rigid repairs that we put in. So what we found over the 3,500 so far, we've only had one failure, and that's purely, I think, because we chose the wrong material to do the repair work with. But the accuracy of the system allows us to keep track of all our repair work that is innovative, to see how the repair materials are performing. So some of those have been in for as long as nearly 4 years now. So from my point of view, it's very good data to have, if you like, for future planning then, about what will and won't work on the network, if you like, in that sense. It also gives us confidence in the sense that when we do try a new product, we can keep a track of it going forward. And so therefore, with the need to introduce lower carbon materials, etc., we can keep a track on those to see whether they're performing as originally advertised or originally suspected they would do. But I think for future planning and maintenance work, this ties into a piece of work that AECOM have been doing around future deterioration modelling, which helps us plan forward for future materials?
So yeah, I think early on in the programme, we realised that the current condition nor the deterioration rates of the concrete roads were very well understood. And that makes it very challenging to set a performance-based asset management strategy and a funding plan, essentially, for these assets that are transitioning. So they're aging and they're changing all the time. So having these surveys and this, we've made reference to the AI defect data that has been developed as part of this work, having that data and information available, it's allowed National Highways SES team, working with our team at AECOM, to develop a data-driven deterioration model for the assets. And this is the first one that exists globally, as far as we know, for concrete roads. So it's a piece of innovation, essentially. So this allows us to predict the future condition of the assets, which in turn plays a very valuable role in terms of asset management. For instance, if we know the condition of our network at a given time, it allows us to predict when each of the assets is likely to need treatment, or when it will reach a condition where reconstruction becomes more cost effective than continued maintenance. So it helps us to prioritise the interventions, to improve the effectiveness of the activities, to plan the budgets, to optimise the budgets, and ultimately to achieve best value so that we can keep the network safe and reliable and open. So those deterioration models, they're developed, they're in use, we're using them now for planning over the next RIS periods. And as we get more data, in, because we've got continued ongoing surveys, and Mark's team are out on the road now, capturing the current condition of the network. We'll rerun the AI, we'll get a new set of defect data, and as we do so, we'll improve and refine these deterioration models. So each time we're getting increased confidence in what the future condition is likely to be.
Just pick up on the AI bit there. We've mentioned it a little bit already. Everyone seems to be talking about it. Could you give us an explanation of how the AI works in this deterioration model?
I'll let Mark explain how the AI works, but it's the output from the AI that we're using. So it's the data output that we're using to develop the deterioration model, if that makes sense.
Yeah. Mark?
AI is allowing us to automate the detection of the defects from the survey information. So when we actually drive with our mobile mapping vehicle, we have a pavement camera, so a very high resolution camera that's looking at the road surface, and that's capturing thousands and thousands of images of each lane of the highway. And what the AI does, it'll actually reviews every picture and it'll automatically detect the defects that it recognizes on the picture. So that could be potholes, it could be cracking, spalling, you name it. And and the way that we kind of develop the AI is we have to train it. So you have to go through lots of the images and label up all the different types of defects that you can see and do lots of those. And as you do that, it learns from that. And then after a while, it can automatically identify those itself. And the way that you can get really good quality AI is by having lots of data and lots of training. Well, luckily on this project, because we're surveying all the concrete schemes, we're building a really good database of data that we can use to train the AI. But also what's really great is working with AECOM and Jess's team there, actually having pavement engineers that really understand what they're looking at to actually do that labeling, because as geospatial professionals, we don't necessarily know the difference between all the defect types, but actually having pavement engineers labeling that up means that we're getting really good quality identification of those defects. Once we've done the survey, we can then run the AI. That will find all the defects on the network and it'll map them all out on the road. And then once we've got that map, that's the information that then feeds into AECOM's deterioration modelling. So they can, based on that information, they can look at what's likely to happen in the future. And then, like I say, when we survey that again the next year, we can then actually sense check whether that deterioration modelling is as we expect.
So what that also allows us to do as well is to produce a bill of quantities very quickly. So when you're developing a scheme and going to scheme delivery, you have a very accurate bill of quantities straight away, which means we can also then tie that in with a cost and a carbon model, which I have, which allows us to very quickly and easily start looking at where we might make carbon savings by choosing certain types of repair material very early on in the design. So therefore we can start to make good carbon choices really before we even get to the ground and through the design process thereafter. So the idea is that we set off with a high level carbon target and look to reduce that as we move through the scheme then on that basis. But the accuracy of the bill of quantities, etc., I can derive at the moment very easily. Saves me an awful lot of work in terms of pulling together the things. I can look at things then more holistically around traffic management, etc., the timing on the road, etc., etc. So having that very early list of repairs to be done, if you like, is a big win for me in that sense in terms of time.
Right, brilliant. So the picture I'm getting is the computer learning, machine learning AI system from KOREC identifies and maps the defects. That goes into the AECOM deterioration model, which then passes through to National Highways' future planning, and it can be overlaid with other systems to try and identify the most efficient and carbon efficient way of carrying out the repairs. How is all of that information and the wider ongoing learning you're getting from this system, how is that shared between all of the stakeholders and the supply chain to help with collaboration across this huge project?
I think the first thing to say is it allows everybody to dip in at the level they want to. If you're working in the early program development side, you'll need a certain amount of information which the portal provides you around bill of quantities, the actual site length, the topography, etc. And then as you develop the design, it goes off into scheme development from my point of view with the designers. It allows them accurate information to work with very easily. And then the final bit, when we hand over to construction, it allows the construction people to start very early planning, very early contractor involvement, if you like, around how they might deliver the works, what things they might do, amount of plant they need to bring to site, etc. So collaboration is strong. The other thing that's worth mentioning, because this is a 30-year program, is that there will probably be in the region of 30 to 40,000 people come into contact with the portal. So being able to share that history of information is also equally important. So as contractors come in and out, as personnel change, it's important to have a solid body of evidence, if you like, about what has or hasn't worked, so that when people like myself retire in the next RIS period, whoever replaces me will be able to pick up the reins and move smoothly forward with a full understanding of what's been done before.
Yeah, really exciting thought, isn't it? Passing on this information, what we might be like, what AI will be running on this data that you guys have collected and processed in another generation's time.
But also we have effectively an end-to-end digital working group where we're regularly reviewing with all of the contractors on the framework what kind of information do they need to have, what kind of functionality could we implement that would really help them do their projects. So that even that portal itself is a evolving platform, and where we're tailoring it to constantly drive more efficiencies depending on what it is that people want to do with it. And I think it's important when we're moving from an analog to a digital process here. So in some ways, sometimes we're removing or replacing tasks that are being done manually at the moment. So, we've got to recognize that there's a transition there, and for some people that will go faster than others, and other people that will be slower, and we don't want to create a situation where we're adding another task to do. This has actually got to be, making an existing task digital and faster and improving. So it's important that we have all the stakeholders feeding into this for it to be successful and to be adopted quickly.
AECOM have been helping us with a number of different bits and pieces that help support the portal. So one of those is the concrete pavement maintenance manual, which Jessica would like to speak a bit more about the effort and work that went into that.
Yeah, I mean, the last version was published in 1990 something, the early 90s. And largely, since the concrete roads were built, they were there, they just did their job quite nicely, and no one thought much about them until recently. They're reaching the end of the life now, and there's significant need now for intervention, for maintenance, and for reconstruction in many cases. So yeah, Mike's team quite rightly identified a bit of a gap in the industry in skills and knowledge. So yeah, we supported National Highways to rewrite the concrete pavement maintenance manual. It's now available online, and it really it's there to share industry best practice, and to improve consistency in how we deliver maintenance. So simple things like even how we recognise and classify defects. There's a visual guide there. There's treatment options guides. You know, how long, if I do this repair in this location, how long is it going to last versus this repair? Then it helps you to assess in a more informed way, you know, what the best options are for intervention and whole life cost.
So the aim long term is to take the paperwork and the manual, if you like, and put it into the portal so it becomes automated. So you can then look at a 5, 10, 15-year repair strategy for the pavement, if you like, going forward. So we're learning how to do that at the moment, but we needed to update a lot of the things around the portal in order to make the portal work more efficiently. And that's just one example. Another one we've also been working on, which will be part of the future development of the portal, is looking at how we recycle. So knowing what the volumes of material we took out and what we do with those and how we dispose of those isn't currently in the portal, but as part of the future developments. AECOM have been doing some work with us again around recycling, and would you like to speak a bit more about that, Jess?
Yeah, so on a lot of these schemes, there's a large number of concrete bay replacements. So where you've got a shattered, cracked slab, if we want to keep that asset going and extend the life, then it's quite common for us to do a bay replacement in those locations. And it's actually generating quite a lot of concrete arisings out of the roads. And one of the benefits we've got here is that we've got a very consistent source of material because you've got a large material coming out of one asset. So Mike's team are now we're kind of switched how we look at the assets. So Mike's team are taking a value approach to the assets. So instead of treating these bays that are coming out, these materials, as waste, the emphasis now is how can we gain best value. So the project that we've just delivered is looking at how can we assess the materials that are in the asset to understand the quality of them and the suitability, but then how can we process them to get best cost and carbon from the materials. So we've looked at using the concrete arisings coming out of the schemes to process them and use them into precast concrete that can then go back into schemes in a circular economy way.
So what the portal does allow us to do is we checked QRF codes to the actual new products we produce from that. And again, what we can do with Mark's portal, if you like.
What QRF codes mean?
Yeah, basically it's like a barcode. It's a plastic insert we can put into products. So we put that in a barcode, read it. It means that potentially with future developments with the survey system, we can actually detect where those come back onto our network. So if they do come back onto a network, we know exactly the provenance of that material, when it was pulled up, when it was manufactured, and where we've now placed it for future use. So that kind of future recording of assets is also quite important. So Mark, would you like to say a bit more about that kind of capture of data?
You know, that there's lots of different types of information that we can include in the portal to get an even greater picture over and above what we've already done. So for example, like I say, we're already capturing LiDAR and imagery. Working with Mike, we've also been starting to capture ground penetrating radar information. We've even been capturing things like thermal imagery, very high resolution imagery. We're looking at capturing noise information along the road, and even integrating with live IoT sensors that we can embed in the road. So, you know, there's lots of different sensors, lots of different information that we can capture and bring together to create an even richer digital twin of the network. But then it's a case of like, how do we use that information? How do we get the more value from it? and what does that drive? And actually that feeds to a project it's probably worth mentioning that we're doing with Digital Roads of the Future, which is a National Highway sponsored project with Cambridge University. And one of the objectives of that research is around how can we create an exemplar digital twin, the most detailed digital twin possible, get the best picture of the road possible using the latest technology.
Just explain a little bit technically how that works. These are sensors in the road, at the side of the road, monitoring pressure, consistency of the material.
Yeah, so one of the things when we started the program was we realized we didn't know a lot about how concrete moves with the various thermal effects on it during the course of a year, how much water gets down between the cracks, if you like, and into the base below the pavement, or just runs off the pavement. So we started to instrument, if you like, a number of slabs. We did a test slab up in one of our depots at Spinner Row in Norfolk. We have one live on the A14 at the moment, junction 54. And we've got two more going in between Newmarket and Cambridge at the moment. And the idea about that is to confirm some of the resources we collect from the AE survey, if you like, around things like the nature of the movement of the slabs. We can see, for instance, if slabs move past each other, the actual micro level of that is quite important. So the number of freeze-thaw events in the year, the actual temperature range in the year, if you like, for certain slabs. And one of the big surprises we had this last year with the really hot wave we had was one of the slabs actually gained 27 degrees centigrade in a single day, which is huge. In terms of concrete movement, that's probably about 3 to 4 millimeters of movement. And when you consider that every single slab is trying to expand at that rate, that's when we get some of the more dramatic kind of blow-ups and deterioration, if you like, on the network. So understanding the minutiae of that and linking it back to the surveys we're doing is also important. The other thing we've also traditionally do is cores on the road. So we take a core of a particular section of the road and we try and extrapolate from that the whole environment around that core. So it might take a core every 200 meters, but that could be a very localized core, not providing us the full information. But what we can do is tie it back into the GPR now to see with what we've seen in the core that we took actually matches the GPR. So things like boundary layers in the lower levels, water below the slab, and things like that, which gives us an indication where the water's running through the joint, and the sensors then help us prove that it's taken place. So we have a number of working theories about how pavement goes from being quite stable to suddenly breaking apart. We had 139 small road closures last year because the pavement deteriorated because of the heat. And we're determined to try and understand that further so we can take more proactive measures to stop that happening. So typically the worst ones take about nearly a day, 2 days to repair. Other ones take perhaps just a matter of a couple of hours. But if we could stop that happening altogether, that's a lot less disruption to members of the travelling public using our network, and better customer service, if you like, to our customers about the reliability of the road surface. So all of this ties back in. And what we're hoping to do with the portal is to include the sensors live into there, so we can have a look at the data we've collected with the surveys, as opposed into live data coming in, etc.
The sensors are actually embedded in the road.
Yes.
Yeah.
So that we've got special sensors that look at the road from above and in the road and below the road. So we're going down to about 1.5 meters deep at the moment to see what goes on at the very depths below the road, which is something people haven't done before. So the idea is to collect the data, create a huge data lake, and then start to analyze which are the key factors, etc., to do with the pavement. And certainly for local communities, if we can improve the noise, as we have done with some of our sections, so they're actually quieter than asphalt roads, that's a huge win for the local population in terms of the day-to-day distraction and overall environmental noise in a particular area.
Yeah, that's fascinating. Lots of world firsts on this project, all over the place. I love it. How are you building in benefits in the short term?
As we move forward into scheme design, we are looking forward to being able to virtually walk the road, to look for hazards and things like that, to use augmented reality more for everybody on the site in the program, to see what's coming up and to see how we might solve problems before we get to site, if you like, in that sense. So a good example of that is where you have a taper for traffic management cones coming into a roadworks, being able to walk it virtually to see whether it's correct, or you've left yourself with a problem you had anticipated. So again, it's that digital twin of what could we do different, or what alterations can we make to make it better going forward? What kind of things do we need to make people aware of in various stages of construction? So that could be, for instance, hot works or breakout, where we've got lots of concrete flying around with the breakout processes, the number of lorry movements, all of which pose health and safety risks, if you like, to workers on the site. And it's been able to identify those ahead of time in things like clearance zones, the amount of space you need for hot works, confined spaces where there might be some on the network. So all of those allow the construction teams to start thinking very early and walking through the design, if you like, and spotting things that they would need to be accountable for when we come to site construction. And at the back end of that, then, we get a really good health and safety file about what's been done, what actually happened, which days, which shifts, what the weather was like that particular day, how much plant was on site, which plant was used where. And so when we do the handover, we get a far more complete handover now than we've had before, which means, again, when the construction teams come back, when the designers come back again to do further work on that section of road, and we envisage that might be 3 to 4 schemes over a 30 or 40-year period to keep the road going. That allows the previous team, if you like, to see what the others have done as part of their processes going forward. But that's only possible through accurate capture of the data right up front in the beginning.
I guess the mapping must really help with that as well, Mark. So we can identify
I think
places where there may be risk.
So there's obviously a lot of different benefits you can identify. I think there's obviously the commercial benefits and cost savings from using a digital approach. I think the report that we did, I think, shows with the current level of end-to-end digital that we have, potentially £3,900 per lane kilometre saving from deploying an end-to-end digital solution. So that in itself is a huge amount when you add that up over all of the schemes and work that needs to be done. But I think in addition to that direct cost saving, which is largely seen, I would say, in the optioneering stage in terms of using that information to inform the optioneering, not having to go out and do more traditional surveys where you've got to close roads to get that information. Also, we're seeing a lot of that saving in the construction and the handover stage is where we're seeing a lot of saving as well. I think what's been identified is there's even more kind of cost savings to be made if we can do a bit more work around design and actually doing more centralized digital design within the portal. At the moment, people tend to take that information and put it back into their own environments, do the design, and then put it back into the portal. Whereas if we were able to kind of stay in that same environment, there's further cost savings to be made.
Fascinating project. The bitter envy of every local authority, I'm sure. What is the future? Because obviously you've got a brilliant setup here for concrete roads. I would imagine the obvious thing is to expand this to all of the motorway network. But where do you see this going, Jessica?
Yeah, I think what we've developed here is a really strong proof of concept, and we're already delivering value to not just to National Highways, but the whole supply chain and the customer ultimately. I think this can be scaled up very easily and naturally, can be scaled up to the whole network. And I think in doing so, the efficiency and the value that's gained from that will scale up accordingly. So I see it as a bit of a no-brainer, to be honest, to have this valuable data all in one place for the whole supply chain.
Right, so a no-brainer. Michael, you're the client. Do you agree with that? Are we going to see this expanded?
I hope so. I think what the lessons we've learned here, certainly, and National Highways itself is working on a digital roadmap. We've got lots of different assets, so whether this fits all assets remains to be seen. And I think the approach we took here is we have lots of small defects and lots of small repair work to do compared to an asphalt road where largely we're playing off large areas, if you like, and put back in various layers. This is more about metre square repairs, half metre square repairs that need to be done to keep the road safe, if you like, and that requires a different approach, which this is more than delivered on in that sense. So alteration to other types of asset and types of pavement probably take a little bit more work, if you like, and within the business as a whole of National Highways to see how that fits in with its overall digital strategy. I think one of the points we haven't really touched on is, what does this mean for the future? We need to know accurately where we are on the road for things like self-driving cars in the future. We've started to look at things like healing materials, which can be injected into the road, to know exactly where those go and the benefits those give, because those are a long-term repair. Also things like automating repair vehicles, etc., and things like that, so they can be self-aware, self-driving, perhaps with just only one person looking after 6 or 7 repair vehicles on the network is important. And we can only do that if we have the digital format to work in to enable the vehicles, if you like, to be aware of their surroundings and where they're supposed to be going, what they're supposed to be repairing going forward. So that's part of it. I think overall, it's the sum of all things, in the sense that it brings in lots of different things together. We are truly beginning to exploit what do we do with the carbon, what do we learn from the carbon and materials, and how we handle things and things like that, and keep a track of it. The rate of data collection overall from what we're doing now is such that I think it will probably be another 5 to 6 years before we fully get to grips with the full capabilities of what the portal can deliver. And I'm being extremely excited, if you like, from what the work we've done so far to see where we can go in the future with this. I think there will be a lot further integration into schemes and how we deliver, how we develop, how we asset manage the asset going forward in the future as well.
The acquisition of the data is almost becoming the easier bit. Where we're going now is extracting the value from that and applying that to a use case. And that's, like I say, why the continuous development of the AI is important for us, because that will help us get more and more value from that data that we're capturing. So an example of that is some of the work we're doing with AECOM at the moment, of trying to further improve the AI by, okay, we can identify there's a pothole there, but actually if we cross-reference that to the LiDAR information, we can tell that what is the size of that pothole, what is the depth of that pothole. With that information, we can actually start doing even better design. So the more value we can extract, and the quicker, the more applications that it can be used for. And I think, we've been very focused on the pavement here, the actual condition of the road asset, but this is a mass data capture technique. So we're surveying everything we can see. So we've actually got a lot of other information there that we're building around the roadside assets, the verges, the vegetation, the bridges. There's probably lots of other information and value we can get from this same data set, and that requires more and more stakeholders and bodies coming together to get the most from this. So opportunities are endless, but I think what's been really great about this project is that communication and bringing all the parties and stakeholders together and getting National Highways to drive that centrally, which actually stops that kind of working in silos and means we can really benefit from a true end-to-end digital approach.
Brilliant. Well, that's a great place to end. I hope the sector embraces this change, because it sounds fantastic. I have to say, I feel a little bit like the Wizard of Oz. Mark, you're the heart of this, Jessica, the brains, Michael, the courage, and I'm just the idiot behind the curtain pretending they know what they're talking about. But it was a fascinating conversation, really, really interesting and really exciting projects, and I wish you the best of luck. And I'm sure, in the future we'll all be owing you a great debt because of the foundations you've laid today. So I hope all of the viewers have enjoyed this as much as I have. Please do stay to the end of the video, where you can get some more contact information. You can find out more about this amazing project and hopefully bring it to a network near you. So thanks very much for watching. Thank you to all of our guests for joining us, and thanks to our viewers. As always, safe travels, everyone.